Hi students, in this video we will discuss bubble sort. First we will discuss the procedure of bubble sort, how the elements are sorted. Then we will discuss the program with tracing. Okay, now let us assume that we have some elements like 30, 20, 50, 10, 25, or you can take any elements 24 or 25. Now here let us assume that we have 5 elements. So let us assume that these are the elements available in an array. Now what are the index numbers? 0, 1, 2, 3, 4. Okay, because the index of the array starts from 0 and set size -1. So the procedure, so first of all, what is sorting? Sorting means arranging the elements either in ascending or descending order. Now in bubble sort, the procedure here is, so two adjacent elements are compared. So two adjacent elements are compared in bubble sort. Now here let us take iteration by iteration. Let us see. Now let us sort the elements in first iteration. Now here this we will consider it as iteration 1 or pass 1. So some people will call it as iteration 1 or pass 1. What happens in bubble sort? How to sort the elements? So initially two adjacent elements are compared in this technique. Now here the first element is compared with second element, 30 and 20. 30 greater than 20. If the first element is greater than second element, then those two elements will be interchanged. Interchange means swapped. So 30 is greater than 20, yes. So tell me what happens here. Now as 30 is greater than 20, now the elements will change their positions. The first element will be 20, then 30, 50, 10 and 25. 25. So so 10 and 20 are compared. Then next we will compare, we need to compare second element with the third element. 30 greater than 40, 30 is greater than 40, false. So false means they are in correct position, no need to interchange those elements. Then next we have 20, 30, 50, 10 and 25. Then we need to compare third element with the fourth element, that is the third position element with the fourth element, fourth position element. 50 greater than 10, yes. If it is true, then we need to interchange these two elements. As 50 is greater than 10, 50 will come here and 10 will move here. So that is interchanging or swapping we will call. Then now we have 20, 30, 10, 50, 25. Because these two elements are interchanged. Then again, in the next case, compare fourth element with the fifth element. 50 greater than 25, yes. Then interchange those two elements. As 50 is greater than 10, then interchange those two elements. Now we have 20, 30, 10, 50 and 25 and 50. This is the end of first iteration. Now if you observe carefully, after completion of first iteration, the last element is pushed to the greatest element is pushed to last location. Now we can say that this element is in sorted list and the remaining 4 elements are in unsorted list. Okay, so after completion of first pass or iteration 1, so the largest element of the list is pushed to last location. Now the remaining elements will be considered as they are in unsorted list. Then the element which is pushed to last location, that is the greatest element, we will consider it as sorted list. In the next iteration, we will compare only these 4 elements. We will not compare the sorted list. We need to compare only unsorted list of elements. Now in the next iteration, iteration 2, now we have, what are the elements we have? We need to take the elements which are end of iteration 1, what are they? Those we need to take. 20, 30, 25, 50. 50 is already sorted, so we will not compare 50. Now in the iteration 2, what will happen? Again, the comparison begins from, in bubble sort, every time the comparison begins from first location. So 20 greater than 30. Is 20 greater than 30? False. Means they are in correct position. No need to interchange. Then we have 20, 30, 10, 25, 50. Then we will compare the elements with second and third element. 30 greater than 10, S. So S, so we need to interchange these two elements. 10, 30 and 10 should be interchanged. So after interchanging, the order here is 20, 10, 30, 25 and 50. Then in the next case, we need to compare third element with the fourth element. 30 greater than 25, S. Then as it is true, we need to interchange these two elements. Now we have the elements with 10, 20, 10, 25, 30, 50. 30 and 50. Now, so no need to compare 30 and 50 because already 50 is in sorted order. Now this is the end of pass 2 or iteration 2. Then after second iteration, so these two elements are arranged in sorted order. That is, last two elements are arranged in sorted order. Then we can say that these two elements are in sorted list and the remaining three elements, the remaining elements are in unsorted list. The remaining elements, we say that they are in unsorted list. So in the next iteration, again what we need to do, so these elements we need to take as input. Then we need to arrange these elements in the next we need to arrange these elements in the sorted order. Now let us assume that in the next iteration the input here is, so these elements we need to take, that is 20, 10, 25, 30, 50. 30 and 50 already sorted. Now if you observe here, even 25 is also in sorted order, but we will not consider it is sorted. Okay, by seeing we can say, but in some cases that may or may not be in sorted order, so we will not consider this 25 as sorted. After second iteration, only last two elements only we will consider as sorted. Now in the next iteration, again compare 20 and 30. 20 greater than 30, S. Then interchange these two elements. Now we have 10, 20, 25, 30 and 50. Now here already these elements are in sorted list, no need to compare. Here in this case 50 is already in sorted list, so no need to compare this 50. Okay, now again we need to compare second element with third element. 20 greater than 25, false, no need to interchange. Now if you observe here, what happens after third iteration, that is after first, second, third, after third iteration, last three elements are in sorted order. 10, 20, 25, 30, 50. Even though the complete list is sorted, we consider that these last three elements are in sorted list and these two elements are in unsorted list. Now we'll go for again next iteration. So in the next iteration, again what we need to do, so take these elements 10, 20, 25, 30, 50. Now no need to compare these three elements in this order because they are already sorted. Now we need to compare only 10 and 20. 10 greater than 20, false, because they are already in sorted order. No need to change these elements, interchange these elements. So now finally the sorted order here is 10, 20, 25, 30 and 50. So there are 5 elements. So how many iterations it took? 1, 2, 3, 4 iterations. If there are n elements, it will take n minus 1 iterations. It will take n minus 1 iterations. Okay, this is bubble sort. Now there is one advantage in bubble sort. There is one advantage in bubble sort, so which is not available in other sorting techniques. Now let me explain that part first. So now I will remove this part, then I will explain the advantage of bubble sort. Suppose, let us assume that if user enters the list, the advantage of bubble sort. Suppose if user enters the list as 10, 20, 30, 40, 50. Let us assume that user enters the list in this way. Now generally what we will do, we need to compare the elements. So 10 greater than 20, false. 20 greater than 30, false. 30 greater than 40, false. 40 greater than 50, false. Means, so in the complete iteration there is no interchanging of elements. Even one element is also not exchanged its position. Then we can say that all the elements are in sorted order. It is not required to go for next iteration. We can stop the iteration here itself. So one advantage here in bubble sort is, if the number of elements are n, generally it will take maximum n minus 1 iterations. Minimum iterations can be 1 to n minus 1. So minimum it can take either 1 iteration or 2 or 3. At any time it comes in sorted order, we can stop comparing the next iterations. We can stop. That is the main advantage with bubble sort. This I will trace and show you in execution part. How many iterations it will take, that also I will show you. Okay, now this is bubble sort. Now here if you remember the so which two elements we need to compare? Two adjacent elements. Now let us assume that, so this is j is pointing to the first element, index of the first element. J points to the index of first element. Now if this is j, we need to compare the adjacent element, next element to it. So what will be the index of this? J plus 1. Yes, it is j plus 1. So what we need to do? We need to compare. So the logic here is, we need to compare. This is important. So here mainly we need to compare if a of j, a is an array, j is the index. If a of j is greater than a of j plus 1, if a of j is greater than a of j plus 1, then interchange those two elements. Interchange means what we need to do? So temp equal to a of j, then a of j equal to a of j plus 1, then a of j plus 1 equal to temp. A of j plus 1 equal to temp. A of j plus 1 equal to temp. This is interchanging. This is only for first element and second element, but I want to perform complete iteration. So what we need to do here? So we need to take one loop. So here take one j loop for j equal to 0, because in every iteration we are starting from 0. J equal to 0, j less than n minus 1 minus I, then j plus plus. So what is this j less than n minus 1 minus I? Because n minus I, because the number of elements are 0 to n minus 1, because so we will take j and we will compare with the adjacent element. So j we will stop at this point only, because if it comes to here, j plus 1 means this garbage value it will take. So we will stop here only. So n minus 1 minus I. Why? Because we have seen we no need to compare. After first iteration, no need to compare the last element. After second iteration, no need to compare last two elements. So if you use minus I, it will not compare or it will not check the sorted list. This is minus I is used to avoid comparing sorted list. Avoid comparing sorted list. If you do not use minus I, our program will execute, but unnecessarily it will compare even the sorted list. Okay, so this is for one iteration. Now we have, if there are n elements, n minus 1 iterations it will take. So what we need to do? Add one more loop. So for I equal to 0, I less than n minus 1 I plus plus. Why n minus 1? Because if there are n elements, it will take n minus 1 iterations. So this is the main loop for bubble sort. So this we will write inside the function. Please concentrate carefully, see the execution. I will trace and show you the program. Then I will explain the main advantage of bubble sort also. Okay, please watch the execution carefully. Okay, now so here you can see the output for this program. So this is the complete code I have. So main same as previous, like selection sort, whatever we have written. So this process is not required. So hash include stdio. This is function declaration. Then declaration of variables, accepting the array size, accepting elements into the array, calling the function a comma n. So a is an array, n is the number of elements. This is after sorting, the elements will be displayed on screen. Now bubble sort. Observe the logic carefully. So bubble sort of int a of comma int n. So I comma j comma temp. So if a of j greater than j plus 1, that is if two adjacent elements are compared, so then if it is greater, then those two elements will be interchanged. Okay, now listen carefully ma. In this case, if there is no interchange, in this case n minus 1 iterations it will take. Okay, now I will trace and show you the program. So here take here main dot a. Okay, so initially it contains zeros. Now let us accept the elements. Let us take only 5 elements. So enter the 0th element. So 30. I'll take the same elements. You can take in any order. 30, 20, 50, 10, 25. Okay, or you can take any elements, no issues. Now we have 30, 20, 50, 10, 25. Calling the function. Called the function. Now here just I will show you a of j and a of j plus 1 and temp. Okay, then if you want you can take I value also. Now let me trace the program. Here I equal to 0, j equal to 0, j value also 0. Now so j greater than a of j plus 1. What is a of j? 30. A of j plus 1, 20. 30 greater than 20, s. So it enters into this block. So these two elements will be interchanged. Now you can see here 20 and 30 are interchanged. Now again j plus plus. Now j value becomes 1. A of 1. Now what is a of 1? 30. A of 1 plus 1, 2. A of j plus 1 is 50. 30 greater than 50, false. So it will not enter into this block, no interchange. Now j value becomes 2. A of j is now 50. A of j plus 1 is 10. 50 greater than 10, true. It enters into this block. Then those two elements are interchanged. You can see here. Now again a of j. Now what is a of j? It is a of 3. What is a of 3? 50. J plus 1 is 25. 50 greater than 25, s. Again it enters into this if block. Then those two elements are interchanged. Now if you observe, I value becomes 1. That is, one iteration is completed. Now 50 went to the last position. 50 went to the last position. Now again j starts from 0. Now 20 and 30 are compared. A of j and a of 20 greater than 30, false. J plus plus. Now j value becomes 1. So a of 1 is now 30. J plus 1 is 10. 30 greater than 10, s. Again it enters into this block, interchanges those two elements. Now a of j is 30. J plus 1 is 25. These two elements are compared. 30 greater than 35, s. 30 greater than 25, s. So enters into this block, interchanges these two elements. Now you can see second iteration is completed. Last two elements are arranged in sorted order. Now I value is 2, means third iteration. Now again it enters into this block. Now A of j is comparing first and second element. 20 greater than 10, S enters into this block. 20 and 10 are interchanged. Again now 20 and 25 are compared. 20 greater than 25, false, no need to interchanged. So it is coming out of the loop. Again it is going to ith loop. So because it will not compare these elements, then again it enters into this block. J value becomes 0. 10 greater than 20, false. Now J value becomes, so it will not compare, then comes out of the loop. So it goes back, then displays after sorting. So here you can see after sorting it displays 10, 20, 25, 30, 50 will be displayed onto the screen. Okay, so this is bubble sort. Now please observe carefully. I will show you, I told you that after so I will show you after each iteration how the elements will be displayed. Now print f after pass 1, you can take out after pass percentage d colon I plus 1. Now I am displaying the elements for j equal to 0, j less than n, j plus plus. What is the order of the elements? I am displaying onto the screen. Printf percentage 5d comma a of j. Now I will use here get ch for explanation purpose. It stops the execution of the program. In dev this get ch will not work. Now let us run this program. Control F9. Enter the array size 5. Now let me take the element 30, 20, 50, 10, 25. Let us assume that these are the elements. After pass 1, what is the order we have? 20, 30, 10, 25, 50. Now after pass 2, what is the order we have? 20, 10, 25, 30, 50. Here we forgot to give slash n, that is my problem. Next, after pass 3, 10, 20, 25, 30, 50. After pass 4, 10, 20, 25, 30, 50. Then after pass 5, this is the order. Then after sorting, 10, 20, 25, 30, 50 displays onto the screen. Okay. Now here because it enters into the loop, sorry, here we need to use n minus 1. That is why extra pass it has given. Okay, now let me trace and show you once again. Let me execute this part once again. Please observe carefully. Here I will show you, it will stop in the middle only. Enter the array size 5, 30, 20, 50, 10, 25. Now after iteration 1, this is the order. After greatest element is pushed to last location. This is after iteration 2. After pass 3. Then after pass 4. Then after sorting. Now let me trace this program. Run your program. Now enter the array size 5. Let us assume that I have entered the first element 5, second element 1, 2, 3, 4. Now if you observe here, after first iteration only the elements are arranged in sorted order, but it is taking again 4 iterations. To avoid this problem, what we can do here is, suppose if the elements are already in sorted order, or if it comes to sorted order after first iteration, then no need to go for next iterations. For that, what we will do here is, we'll take one variable called exchange. What is that? Any name you can use. So exchange. So initially in every iteration, so exchange equal to 0 means exchange not happened. Then inside this if block, when exchange will happen? If the control enters into this if block, exchange equal to 1. So if there is no exchange after coming out of the loop, if there is no exchange of elements, then if exchange equal to 0, if there is no exchange of elements, what we can call break. This break statement will take the control out of the outer loop, that is ith loop it takes. So it will not go for next iteration. If exchange value is 1 means some interchange is there, means it will continue. Now let me trace and show you the program. Enter the array size 5. Now 30, 20, 50, 10, 25. So after iteration 1, interchange is there, so it displayed iteration 1. Second iteration, S interchange is there. Which elements are interchanged here? 30 is pushed to second last location. Now again here also interchange is there. That is 10 and 20 are interchanged in pass 3. Next, in pass 4 there is no interchange, so through break it come out. Now suppose if there are 5 elements, how many iterations? N minus 1 iterations I told. Now 5. So 5, 1, 2, 3, 4. Only in the first iteration all the elements are in sorted order. In the second iteration there is no exchange of elements. Directly it comes to an end. So this is the main advantage of exchange sort or bubble sort. So here no need to display after each iteration, but you can use exchange equal to 0. Then what happens? If exchange equal to 1, what happens? We can use. Okay. Thank you for watching. See you in next video.